Good afternoon, everyone. My name is Hazel Rosales, and I'm here to present the first part of the Chapter 6, The Basis of Business Intelligence Management. So let's proceed with our discussion. The learning objectives after completing this chapter, we MBA students should be able to answer the following questions. What are the problems of managing data resource in a traditional file environment, and how are they solved by a database management system? What are the major capabilities of database management system or DBMS, and why is a relational DBMS is so powerful? Number three, what are some important principles of database design? So, what is data hierarchy? Data hierarchy refers to the organization of data into different levels of abstraction or complexity. So, the purpose of data hierarchy is to create a systematic and structured approach to organizing data so that it can be easily accessed, managed, and analyzed. So the most common levels of data hierarchy are the following. Sa ilalim is bit, byte, field, record, file, and database. So let us discuss one by one what is the meaning of each term. So bit is the smallest unit of data that can be stored or manipulated. It represents a single or binary digit, either 0 or 1. Number 2 is the byte. A byte is a group of 8 bits. Bytes are used to represent alphanumeric characters or other symbols. So the field is a group of related bytes that represents a single attribute or characteristics of entity. For example, in a customer database, a field might be a customer name or customer address. A record, while the record is a collection of related fields that represent a complete set of data about a single entity. For example, in a customer database, a record might be a single customer's information, while file is a collection of related records that represents a complete set of data about a particular topic or subject. For example, in a customer database, a file it might contain all customer records. So the last but not the least, the database, it is a collection of related files that are organized in a structured way to facilitate data retrieval and management. So, the purpose of the data hierarchy is to create a logical and organized structure for data that makes it easy to retrieve and analyze. So, it is also helps us to reduce data redundancy and inconsistency, so making data management more efficient and effective. So by organizing a data into a hierarchical structures, it becomes easier to understand the relationships between different data elements and to identify patterns and trends within the data. So the traditional file environment is a system of organizing and storing data that was widely used before the modern database management system. So while this system was effective before, it is now widely considered to be inefficient and problematic due to several controversies. One of the biggest controversies of the traditional file environment is data redundancy. So in this system, Data is often duplicated in and stored in multiple files, which can lead to inconsistencies and inaccuracies. So this redundancy can also lead to waste of storage space and make it difficult to maintain data integrity. Another controversy of the traditional file environment is the program data dependence. In this system, data is closely tied to a specific application, making it difficult to share data across different applications. So this can result in a lack of data integration, making it difficult to perform data analysis or develop new applications. The traditional file environment can also result in data inconsistencies. So this occurs when different versions of the same data are stored in a different files, making it difficult to determine which version is correct. This can lead to errors in decision making and can compromise the quality of data. Likewise, the traditional file environment is also limited in its scalability. So it is not being flexible. So as data volumes increase, it becomes more difficult and time consuming to manage and retrieve data from multiple files. So this can result in reduced system performance and decreased productivity. Lastly, the traditional file environment can also be vulnerable to security breaches. In this system, security measures are typically applied to individual files rather than the database as a whole, making it easier for hackers to gain access to sensitive information. To overcome these challenges, businesses have turned to database management system as a solution. So what is the database management system? This is a software system that allows users to create, manage, manipulate databases. It is a computerized system used to manage large volumes of data in a structured and organized manner. A DBMS provides a user friendly interface that allows users to perform various tasks such as storing, modifying, retrieving, and deleting data in a database. Some examples of DBMS include MSQL, Oracle, and Microsoft SQL Server. So the DBMS are widely used in various industries such as finance, healthcare, education, and e-commerce to manage and analyze large amounts of data efficiently and accurately. So the DBMS are designed to address, as what I've said a while ago, it is designed to address many of the controversies of the traditional file environment. So here are some ways in which DBMS solves these controversies. The number one, the data redundancy. This problem can be solved by DBMS by eliminating the data redundancy storing the data in a centralized location and enforcing rules that ensures data consistency. So in a DBMS, data is stored in tables and duplicate data is eliminated through normalization techniques. So, number two, for the controversy of data dependence, the DBMS separates the data from the applications that use it, allowing data to be shared across multiple applications. So this enhanced data integration and makes it easier to perform data analysis or develop new application. For number three, controversy, data inconsistency. So the DBMS ensures data consistency by enforcing referential integrity constraints and maintaining transactions logs that keep track of changes to the data. So this makes it easier to determine which version of the data is correct. The BMS also provides the scalable architecture that can handle large volumes of data without compromising system performance. So this is achieved through the use of techniques such as indexing, partitioning, and clustering. Also, the DBMS provides a comprehensive security framework that secures entire database rather than individual files. So this includes user authentication, data encryption, and access control mechanism. So there are several database models that have been developed over years to organize and structure data in different ways. So the relational DBMS is currently the most common type of DBMS for PCs as well as for bigger systems and mainframes. The, the relational model is based on the concept of relations or tables that consist of rows or records and columns or attributes. It represents the data as sets of tables and relationships between tables and established through keys. It is the most widely used model today and supported by the database management systems like MSQL, Oracle, and Microsoft SQL Server. So the Relational Database Management System or RDBMS supports various operations to manipulate retrieved data stored in tables. Here are some key operations commonly performed in relational DBMS. So number one, select. So the select operation is used to retrieve data from one or more tables based on specified conditions. So it allows you to specify the columns you want to retrieve and apply filtering criteria using work clauses. Number two, the insert operation. It is used to add new rows or records to a table. It involves specifying the table name and values to be inserted into the corresponding columns. So if the table has auto-incrementing columns, the DBMS generates values for those columns automatically. Number three, the update system or operation. It is used to modify existing data in a table. It allows you to specify the table, the columns to be updated, and the new values for those columns. So similar to the select operation, you can use where clauses to update specific rows based on certain conditions. Last, the delete operation, it is used to remove or rows or records from a table. So it allows you to specify the table and use where clauses to delete specific rows based on a certain conditions. So these are some of common operations supported by relational DBMS. So the flexibility and power of these operations allow for efficient data retrieval and manipulation and analysis. So the making RDBMS a popular choice for managing structured data. Another model is the cloud-based databases. This is a database systems that are hosted and operated in the cloud environment. So instead of running on local servers, these databases are developed they are deployed on cloud platforms provided by service providers such as Amazon Web Services or AWS, Microsoft Azure, and Google Cloud Platform or GCP. Here are some key points about cloud-based databases. Number one, scalability. So cloud-based databases offer elastic scalability, allowing users to scale their database resources up or down based on demand. So this means that you can easily add or remove computing power, storage, and other resources as needed without worrying about hardware limitations. So high availability and reliability. The cloud-based databases are designed to provide high availability and reliability. They are often used data replication and distribution techniques across multiple servers and data centers. So ensuring that your data remains accessible even in the event of hardware failures or network disruptions. Many as well as many cloud providers offer managed database services which handle routine tasks such as backups, software updates, and infrastructure management. This offloads the maintenance burden from users, allowing them to focus application development and database management. Another characteristics of cloud-based database, it is cost efficient. So the cloud-based databases follow a pay-as-you-go pricing model. So where you only pay for the resources you consume. So this makes it cost efficient, especially for small businesses and startups, as they don't need to invest heavily in hardware infrastructure upfront. Another model is the non-relational databases. It also known as no SQL databases that do not use the traditional relational model of organizing data in tables. So these databases are designed to handle large volumes of unstructured or semi-structured data, and they offer several benefits over traditional relational databases, including um, including the following: the non-relational databases can easily scale horizontally. So number one is scalability. By adding more nodes to the cluster, making them high scalable. Number two, flexibility. So NoSQL databases are highly flexible as they can store a variety of data types, including text, images, and videos. Number three, performance. Non-relational databases are optimized for performance as they use a distributed architecture to handle large data volumes. Number four, cost effective. No SQL databases can be cost effective as as they can be run or on commodity hardware and require less maintenance compared to traditional relational databases. And number five, availability. So non-relational databases are highly available as they use a distributed architecture that replicates data across multiple nodes. Examples of non-relational databases include document-oriented databases like MongoDB, key-value databases like Redis, and graph databases like Neo4j. So the DBMS capabilities in reporting and querying. The database management systems is very powerful. It provides a powerful tools for reporting and querying data stored in databases. So here are some capabilities of DBMS related to reporting and querying. Number one, query language. So most DBMS is provide powerful query language such as SQL that allows users to retrieve data from the database. So the query language provides a wide range of capabilities such as filtering, sorting, grouping, and aggregating data. Number two, ad hoc querying. The DBMS provide the capability to perform ad hoc querying, which allows users to write and execute queries on the fly without the need to predefine reports or queries. Number three, reporting tools. The most DBMS provide reporting tools that allow users to create and generate reports based on data stored in databases. So these tools provide a variety of features such as report templates, formatting options, and charting capabilities. And number four, data mining. The data mining provides capabilities that allows users to discover patterns and insights from large data sets. Data mining algorithms can use to identify trends, clusters, and association within the data. Five, the OLAP or Online Analytical Processing. The DBMS provides OLAP capabilities which allow users to perform multi-dimensional analysis of data. OLAP tools allow users to slice and dice data along various dimensions such as time, geography, or product category and view it from different angles. Number six is data visualization. So the DBMS provide data visualization tools that allow users to create charts, graphs, and other visual representations of data. These tools can be used to gain insights into data and communicate findings effectively. So in summary, the DBMS provide a range of capabilities for reporting and querying data, including powerful query languages, ad hoc querying, reporting tools, data mining, all-up data visualization, drill down capabilities, and schedule reporting. So these capabilities allow users to extract insights from data, gain a deeper understanding of their business, and make informed decisions based on the data. So let's proceed with the database management system design. So this is a process of creating a well-structured and efficient database system that can store, manage, and retrieve data effectively. It involves defining the database schema, determining the relationships between entities, and establishing rules for data integrity. So, entity relationships model, this is entity relationship modeling, is a technique used to represent the entities, attributes, and relationships in a graphical form. So, AR diagrams help in visualizing the structure of the database, including entities, their attributes, the primary and foreign keys, and the relationships between them. Number two is the normalization. Normalization is the process of organizing data in a database to eliminate redundancy and ensure data integrity. So it involves decomposing tables into smaller, more focused tables to eliminate data duplication and dependency issues. So that would be all for my report. Thank you so much for listening and for thank you so much for your attention.